Number 23. Two spheres with radii of r are in contact with each other and attract each other with a force F. If the radii of both of the spheres is cut to half, but the density is the same, what's the new gravitational force between them? All right, so if the original force is F, we're going to call the new gravitational force F prime. So let's take a look at the original gravitational force. So force equals big G times the mass of the first one, which is rho 4/3 pi r cubed, times the mass of the second, all over r plus r quantity squared. Now, after we cut the masses, we're going to come up with a force G and this is going to be 1/2 r cubed times all over one half r plus 1 1/2 r quantity squared. All right, so what we do need to come up with is some sort of relationship that the new force is going to be equal to something times the original force. In terms of the original force is how they want their answer, because everything's in terms of original force. All right, so we know the new force is this. So we need to see, I'm sorry, the old force is this, the original force, and the new force is equal to this. So what we need to do is see what the change is from the original force. So what we can do is say 1/2 cubed is going to be 1/8, and that's going to be multiplied by 1/8. Now in the denominator, what we need to do is get this situation back to the original situation. So what we need to do is pull 1/2 out. So it would be 1/2 squared. And then we would be left with r plus r quantity squared. All right, so the what we have is f prime now. F prime is equal to 1/8 times 1/8, which is 1/64th, over 1/2 squared, which is 1/4. Well, we can drop that 64 down to into the denominator and have 1/64, and this 1/4 in the denominator will invert itself and become 4/64, which simplifies to 1/16. So what we need to do is here is get f prime being 1/16 and say, okay, so that 1/16 is times the original force, which is f over 16th, which gives us D as an answer.